The movement of water and nutrients in and out of ecosystems leads to what we call nutrient cycles. In this lecture, be able to draw and label the water cycle, including the inputs and outputs. Draw and label the phosphorus, nitrogen, and carbon cycles with labeling each output, input, and the major reservoirs. Give an example of how animals move nutrients within and between ecosystems. Give examples of how fungi can make nutrients available. This will touch on previous lectures as well. And name one human impact for each cycle. First off, the water cycle. You probably heard about it in junior high or high school, and you probably read about it in your religious books. It starts with evaporation of water from the ocean. Now, this can precipitate back down to the ocean. That's actually going to be a major part in other cycles as well, because the water can carry various things from the sky to the ocean. But sometimes water will move in the form of clouds over the land, and that's going to cause precipitation over the land. There's also evapotranspiration through the stomata of plants, where the water is going to go through the plants back into the air, and that evapotranspiration can condense, forming new clouds and forming more precipitation over the land. The water can also percolate down through the soil in both runoff and groundwater to get back to the ocean. With phosphorus, you have phosphorus leaving the phosphorus cycle in the form of detritus falling into the ocean floor. Now that's going to cause a lot of sedimentation, which will eventually be reintroduced to the phosphorus cycle through the weathering of sedimentary rocks. So weathering of rocks is going to cause entry of phosphorus into the cycle. Most phosphorus in the phosphorus cycle is cycling, well, of course, through organisms and detritus and going into the soil and coming back into more organisms. Phosphorus tends to stay in an ecosystem for a good amount of time. Now we know that phosphorus is found in things like bones and DNA. And you can also see, of course, phosphorus being deposited from the atmosphere into the oceans. That joins in with the water cycle. As far as human impacts, humans mine phosphorus. The largest pool of phosphorus is going to be in marine sediments, which will eventually be converted into sedimentary rocks. The nitrogen cycle. Well, the air is made of nitrogen, and denitrification, when you convert any nitrogen that's biologically available into simple nitrogen gas, that's going to be the largest output of nitrogen from the nitrogen cycle. And we covered at the whole beginning of life lecture how nitrogen entered the nitrogen cycle. First was through lightning, but it can also now enter through nitrogen fixation, both in the ocean and on land. And this occurs with many mutualistic bacteria and photosynthetic bacteria in the oceans. So mutualisms between bacteria and legumes on land, and the actions of cyanobacteria that can fix nitrogen in the ocean are going to be bringing nitrogen into the nitrogen cycle. We also see the Haber process, where humans are capable of fixing nitrogen by combining it with hydrogen gas under high heat and pressure. A lot of the pool of nitrogen is actually just biological cycling. So much nitrogen is going to be in marine cycling and the cycling of organisms and the soil. The carbon cycle has been particularly interested as we have an increase in the amount of carbon dioxide available in our atmosphere. Most carbon is going to leave the carbon cycle in the form of respiration. This occurs in the oceans, this occurs on land, and we do also see the human impact of fossil fuel burning. Although that is not as large as respiration, it should be noted that the input of gross primary production is the way that carbon enters the ecosystem, and that is roughly equal to the amount that's going on in respiration, both in the soil and by plants. So we can see that adding a new input, such as fossil fuel burning, can really increase the amount of carbon dioxide in the air. And the highest amount of pool of carbon dioxide is actually going to be in carbonate rocks. So carbonate rocks will hold most of the carbon dioxide. We also do see it, of course, in fossil fuels. And of course, another input would be volcanic activity, which in the case of a large volcanic eruption can increase the amount of carbon dioxide in the atmosphere. Now let's look at the biological impacts and ways that different organisms are going to be moving these nutrients. First off, animals move nitrogen within an ecosystem. We can see the excretion of nitrogen. Remember, the excretory system is going to have different ratios with different fish and different amphibians, and this excretion is an input into the ecosystem. It also just cycles it through. We also see subterranean mammals moving soils around and actually depositing low nitrogen soils up onto the earth in the form of molehills. This is a picture of a molehill on St. Martin's campus, and not to make a mountain of it, but what kind of plant is going to be present? Well, legumes are actually present in large numbers. So a lot of those plants are actually legume plants, and those have the nitrogen-fixing bacteria. So by putting low nitrogen soil up on the surface of the earth, the gophers have started a new niche that is quickly taken over by nitrogen-fixing plants. So this movement of low nitrogen things onto the top of the earth increases the nitrogen in the soil, as the legumes are going to put nitrogen in the soil through their actions. Animals also move phosphorus, and there were wars fought over this. You might be looking at this picture of Bolivia, Chile, and Peru and thinking, that's not how the border looks. Not anymore, it doesn't. There was a war fought over guano, cormorant, poop. Why? Because guano cormorants make guano, and guano is a source of phosphorus, and phosphorus is used in making gunpowder. So how do these guano cormorants get all this phosphorus up onto the land? Well, they ate fish in the ocean. Where did the fish get their phosphorus? Well, they got it from marine algae. Where did the marine algae get it? From an upwelling that moved phosphorus from marine sediments up into the ocean column, where there was now high phosphorus in the ocean, causing a boom of life, causing cormorants to eat those fish, and then cormorants had to go back to land, and when they went back to land, they pooped, and when they pooped, you get phosphorus in the soil. And as I said, Bolivia lost the war to Peru and Chile, and part of the Atacama Desert that has all this guano was used for gunpowder. It's a pretty interesting war, and probably not covered in your history book, but it was fought over phosphorus. The role of fungi is in cycling. Fungi can turn lignin and cellulose into simpler compounds, and that's the movement of carbon. Nitrogen is brought back to plants and mycorrhizae because nitrogen is exchanged for carbon by the fungi, and this causes organic matter to not accumulate as quickly. Now, the ratio of nitrogen to carbon can determine how fast fungi are going to be biodegrading things. And we can see the decomposition rates are also dependent on the amount of moisture as well as the carbon to nitrogen ratio. This is why introducing new plants to an ecosystem, if those new plants are adding more nitrogen to that ecosystem, they can increase the rate at which fungi are decomposing things and thus change the ecosystem's nitrogen and carbon cycling. This is also true with earthworms. When you add new earthworms to an ecosystem, it changes the carbon to nitrogen cycling. And if certain organisms, such as oak trees, are adapted to very slow carbon to nitrogen cycling, introducing a bunch of earthworms to an oak forest can actually cause the oaks to not do as well and make other plants that are able to use this high carbon to nitrogen cycling take over the oaks. So succession is actually played out in the soil. We're going to watch a few videos in class. I recommend you watch them on your own, of the role of microbiota on impacts of soil movement. We also can see the human impacts in nutrient flow. So we can see here the Hubbard Brook experiment. What happened is they clear-cut a forest in New Hampshire, and you can see the movement of nitrogen out of that deforested area increases very rapidly after the trees are removed. So clear cuts can cause a loss of nitrogen from an ecosystem. And of course, we're familiar with the human impacts to the carbon cycle. Reducing the amount of forests causes a reduction in the amount of photosynthesis that's going on, meaning fewer inputs into the carbon cycle. And also burning those forests can be an input into the carbon cycle itself. Fossil fuel combustion and industrial processes can also increase the amount of carbon in the atmosphere.